AP Chemistry Molar Conversions, the reaction table method. For quick calculations, say a one-step mole-to-mole conversion or maybe even a two-step mole-to-gram conversions, doing a simple unit conversion is probably the fastest way to go. But if you really want to know a lot about a chemical reaction, the reaction table method is the method of choice. Let's have a look at how it's done through two examples. In this first example, we're burning some butane, meaning that it combines with oxygen to make carbon dioxide and water in the ratios shown here. This is a balanced chemical equation. And if you wanted to know, for example, the combustion of 100 grams of butane can produce up to how many grams of carbon dioxide? Well, you could do a three-step gram-to-gram conversion, or you could write out a reaction table that will tell you a lot. Start with the balanced chemical equation. Beneath that, write the molecular weight, the grams, and the moles involved. Now, the molecular weight is simply the grams per mole for each substance. Butane has a molecular weight of 58 grams per mole, 48 for the carbon, 10 for the hydrogen. These are the average atomic masses that you can find on any periodic table. Oxygen is 32 grams per mole, carbon dioxide 44, and water 18. Fine. These don't add up. They don't need to add up. These are just data. Now, the number of grams that you're given is simply that. From that single piece of data, everything else should fall out. For example, we have a little less than 2 moles. Specifically, if 58 grams is a mole and we have 100 grams, we have 1.72 moles. 100 divided by 58. And how many moles of oxygen do we need? 6.5 times as many, or 11.21 moles. How many moles of carbon dioxide will we make? 4 times as many. 2 gives you 8, or 6.9 moles. 5 times as many moles of water. 2 gives you 10, 8.62. If 44 grams is a mole, if 32 grams is a mole and we have 11.21 moles of oxygen, well, that's a lot of oxygen. That is 358 grams. In other words, 11.21 moles times 32 grams per mole gives you grams. Similarly, we have 303 grams of carbon dioxide, which will be made, and 155 grams of water, which will be made, assuming a theoretical yield, meaning everything goes perfectly, which we always assume for these things, unless we're told otherwise. This is in red because this is the answer to the question. Now, admittedly, this tells you more than you need to know, but this gives you a lot of useful information. It's up to you to decide whether to do a quick unit conversion or to do this entire table. It depends on what you're being asked. This is a great way to see the overall system. Let's do another one. Draw a reaction table for the combustion of 100 grams of magnesium. Okay, I'll talk it through before I go ahead and click. I would start with the balanced chemical equation, which means magnesium plus oxygen is making magnesium oxide. I would recognize that oxygen is O2, magnesium oxide is a +2 -2 system, so MgO should be good, and then I would balance it. I would put that on top just like this. I would write molecular weight, grams, and moles, and this would be the single piece of data that you're given, just like we were here, and everything falls out. Here's the finished answer. Now, if you want, go ahead and pause this and try it yourself. That would be the best way to prove that you know how to do this stuff. By the way, on this one, we're making 458 grams. We must have started with 458 grams. Okay, fine. Let's move on. And somewhere, there it is. Magnesium molecular weights, oxygen molecular weights, etc. The 100 grams was the only thing you were given. Well, that's over 4 moles if 24 grams is a mole. And where'd that 2.05 come from? Well, every mole of magnesium only requires half a mole of oxygen. But it makes 1 mole of magnesium oxygen, hence the 2:1:2 ratio. And where's the question? Draw the reaction table. We'll draw the whole thing. We did, and this should tell us everything. You'll find this a particularly useful method for a free response question where they want to know a lot about a chemical reaction, or if they're asking a limiting reactant question, which is our next topic.